Hey guys, this is Arsham and today we're going to talk about the IP tables as the firewall Linux operating system. So as far as you're concerned, IP table is a command line interface used to set up and maintain tables for the netfiller firewall, which is actually located in the Linux kernel itself, and is operating on both IPv4 and IPv6. And IP tables contain some tables, chains, and rules. And if you imagine that this could be a table, okay, on your Linux router, if you consider this as a router. First of all, there is a table, we call it, for example, filter. We want to filter some traffic. And we've got some chains. So these chains, they include some rules on it. For example, it could be the chain of input, which a packet comes to your router, or it could be the chain of output, which a packet goes out from your Linux router. So basically chains are the input and output stuff. They could be forward, which they actually pass through the input chain, but they're going to be forwarded. Are they going to be forwarded or they are not? That's what we're going to be talking about. And the rules that they specifically tells you if a specific port or an IP address can actually reach the destination or they cannot. That's all being sorted out using the IP tables. So here's our little scenario here. We've got an Ubuntu machine with the IP address of 10.0.120, which the gateway is 10.0.1.1, which is our DB router. It's the Debian, and this machine is going to have the private IP address of 192.168.100.170 with a gateway of 100.2, which is my ESXi server. And the ESXi server is physically connected to my access point, and the access point is physically connected to my wireless radio, and the wireless radio is actually communicating wirelessly with the BTS. Now we're going to see how this stuff are going to work out. So there are some scenarios we're going to work on. First of all, you're going to make sure that you've got some practice labs to do, and this practice lab, you can see I've got two machines. There's a DB router and Deb2, which is my second Ubuntu OS. Let me log into it. All right. So first of all, you've got to install the IP tables, and if you don't know how to install, just search on Google. It's pretty easy. And well, when you install IP tables, there could be some rules predefined. So we're going to make sure that we're going to clean up all of them. So IP tables -t, I'm going to say which table, the filter table, -x and -f means flushing all rules that being defined. I mean, I don't know, could be predefined, whatever it was. Please just flush it all. And you could say IP tables -t filter -nl, which is going to show you all the rules which was specified on the IP tables. As you can see, on chain input, on chain forward and output, there is no rules being specified. So let's write some rules. Why not? So first of all, as a practice lab, I'm going to show you that I can SSH through this Ubuntu server. Then I'm going to deny the SSH connectivity to this DB router. So the IP address of this DB router, which can actually communicate to my Windows PC, is 192.168.100.170. So I'm going to open the CMD and let's SSH through it. SSH 192.168.100.170. As you can see, it can actually connect to my Debian server. There you go. So make exit from it and let's block this bad boy to actually use SSH. So what I'm going to do is I'm going to say IP tables -t filter, which is going to, it's basically saying on the table filter on which chain, on chain input, -p means protocol. The protocol is TCP with a destination port of 22, which is the SSH, you have to know it. -j drop, which means, hey, this is on table filter, and if any packets with the destination port of 22 with TCP coming to my Ubuntu router, drop the packet. So let's see if the computer can actually connect to this. and SSH, and there you go. It cannot connect, and the connection is refused by the Ubuntu router. So that was very basic iptables -2 filter -nl, which means show me all the rules that are being specified to this machine. And it says there is a line on the chain input. The target is dropped. Protocol is TCP port 22, and it's dropped from any source to any destination. Well, that's pretty easy, okay? And well, now we just refuse the SSH connection. So how if I want to do something that my Windows machine cannot ping my router? For example, I can now ping 192.168.100.170, and I can ping my Ubuntu, but let's stop this bad boy to ping my machine. So iptables -a of input, and I'm gonna specify the host address, which is my client, which is my Windows machine, with the IP address of my Windows machine, which is 117.101, and the protocol is going to be ICMP and -j of drop. So let's ping this machine again. So let's see what's on the rules that we are actually pinging again. It's ICMP, right? It's dropped. So it could be potentially because of specifying the host. Let's not specify the host and try again. There you go. My ICMP is being denied. There's no ICMP coming to this machine. So how if I want to delete this chain? How if I want to delete this rule on the chain filter? And if you notice here, I didn't mention the T which was for the filter table. Well, if you don't specify which table, for example, if you don't write -t, like I didn't here, it's by default going to consider that it was for the filter table. So if I wanted to talk about NAT, I have to specify the table NAT. But when you're talking about the table filter, there's no need that you actually need to specify the -t filter. There's no need to. So, and now let's delete this rule, the ICMP rule that is being dropped. So first of all, let's see what's on the table. And as you can see, ICMP for these hosts being dropped, and to any source and destination being dropped again. And if you add line numbers, it's going to tell you which line number it is. 2 and 3, I'm going to delete them. So iptables -d, which is for deleting actually, on the chain input, and number 2 and number 3. Okay, when you delete the second rule, this number 3 is going to be the number 2. So it's like this one. There you go. And I'm going to delete number 2. And now we have to ping the Ubuntu server again. There you go, pretty easy and straightforward. So that was a basic example of the filter table on the iptables. How about the NAT table? Well, there is another table called NAT. Actually, there are some other tables as well. For example, the mangle, the row, and security. And mangle is more for specialized packet alternation, and raw is more because of when you want to track a connection for the pre-routing and output chains. And security is for mandatory access control, which you are going to learn that from your LPIC 304 and LPIC 303, which is for the security courses. Not here really. So let's talk about the NAT chain. What I'm going to do is I'm going to tell this DB router, hey, I'm going to change your SSH port from 22 into something else. And how I'm going to do that? Well, iptables -t NAT, this time is table NAT, -a pre-routing, which means before the packet was routed. And which interface? Well, the interface that I'm connected to the internet, which is the ENS33. So ENS33, and then the protocol is going to be TCP, destination port of 22 and dash J, which is my jump to redirect. And to the port, for example, 2370. So what I basically did is that I changed my SSH port to 2370. So if I connect to port 22, this machine is going to redirect the traffic to this port. But hold on a second. The SSH itself is going to listen on the port 22 by default. So I have to change that. The SSH and SSH config. So, oh no, it's not here, sorry. It's an SSH. It's going to SSH config DI. No, it's not a config, it's a directory. Hold on a second, it's going to be here. Port is 22, it's 2370. And don't forget to restart your server, it's not going to work. It's SSH on sent to us, I suppose, and SSH on here. So I've now redirected the traffic to another port. So let's see if we can connect to the port. Actually, if I use a PuTTY, that would be even better. I'm pretty straightforward. There you go. I can connect using the SSH on a different port, which is 2370. And I redirected the traffic. So that was another example. And how if I want to make this machine into a real router? So this machine, deb2, is by default going to have no internet connectivity. And I've told you that by this scenario, this little guy here needs to connect to the internet. And his gateway is our DB router. So this DB router should be configured as NAT, a NAT server. And if any packets from this machine comes to the DB router, is going to be translated to these IP address, which we call it the masquerade NAT, which basically means, hey, if any packets come from your A01, translate it to your outgoing interface and your output interface, which is the masquerade NAT. So let's config. This is our deb2, and as you can see, there is no internet connection. An IP config, sorry, it's IPA 10.0.120, and IP route, which is a default route, add default with 10.0.1.1. So 10.0.1.1 is this machine, and I've told this machine that your gateway is the DB router 10.0.1.1. You can see here 10.0.1.1 is ENS 38. So I'm going to config this machine to act as a router. And how is that? Well, the config, I guess. There you go. Well, on this directory, etcctl.conf, make sure that the number of net IPv for IP forward is a number of 1. And uncomment it. And then save your file. And this machine is now going to act as a router. So it's very important for you to know that. That's quite important. You just have to know it. And there's other stuff that you have to check on. It's on proc sys net IPv4 and IP forward. The number is 1. It's very important, the number. Look, if you put the numbers 1 in here, your machine is going to act as a router. But as soon as you reboot your router, this machine is not going to act as a router anymore. So that's why we've configured this etcctl.conf file into the number of 1, this net IPv4. So if your machine reboots again, this machine is going to act as a router again. So, it's kind of a persistent changing. That's very important. And for iptables, there is a configuration for you that you have to know if you want to persist your old configurations, that when you reboot your router, those configs and rules are there again. So simply by typing sbin, and I guess it was on yes, iptables-save, and copy the etc iptables rules.v4. So now every single rules that we've configured is now committed to this machine. So let's configure our masquerade NAT. So iptables dash table NAT, okay, dash A on post routing. I mean, when the packet was routed, dash out interface of ENS38. I suppose that was 38. Let's see. Well, the interface that has the internet is going to be configured as masqueraded, which means use this IP. So it means ENS33, this one. So it means ENS33 -J masquerade. And you have to specify the chain forward. Let's say any packets that was about to be forwarded is going to be accepted. From which interface? Well, from this interface, which is the ENS38, I suppose. Yes, -J accept. So now let's try again if we have internet connectivity. There you go. And look at here, the TTL is the number 127. What does that mean? Well, that means that TTL is being decreased by 1. It was 128 and now it's 127. So this machine is connected to a router, which is a DB router, and DB router decreased the TTL number by 1, which means that we know that we are connected actually to a real router. And then this machine is going to go through the internet. So that was all about iptables, guys. I hope you enjoyed my explanations about iptables. That was a brief scenario, and subscribe my channel for more videos.